Come on guys, let's do this problem right here. The question is asking, they have given a matrix and asking to find the a power 100. So in this case we have to choose eigenvalue to find this one. So let's see how we can do this. So first of all, I have to find the eigenvalue. I have to set this one into set this determinant a minus lambda I into 0. So if I do that one, I can find eigenvalue. So I have to find eigenvalue and eigenvector, both of them to do this question. So in this case, let's see what we get for eigenvalue. So to get the eigenvalue, now I subtract this one. So in this case, if you this is the identity is going to be something like this. So 1 0 0 1, this 2 by 2 matrix. So if you multiply this one by lambda lambda lambda, this will be lambda lambda. So if you deduct this one, it's going to be determinant of 7 minus lambda, then 10 1 minus 2 minus lambda. So this is equal to 0. Now you know to find the determinant we use AD minus BC. So AD minus BC is going to be minus 2 minus lambda times 7 minus lambda minus BC is going to be minus 10. It's equal to 0. And now I can multiply this one, so it's going to be minus 14 plus 2 lambda plus 2 lambda. Then here we have minus 7 lambda, then plus lambda square minus 10 is equal to 0. And if I simplify this one, if I take the lambda square front, this is going to be lambda square, and minus 7 plus 2 is going to be minus 5 lambda, minus 14 plus minus 10 is going to be minus 24 equal to 0. Now I have to factor this one. So in this case, when I add, I have to get negative 5, multiply negative 24. So negative 8 and 3 will work. 3 will work. So I can take that. Lambda square minus 8 lambda plus 3 lambda minus 24 is equal to 0. Now I can take the lambda common right here. So if I take lambda common, it's going to be lambda minus 8. If I take 3 common, this is going to be lambda minus 8 equal to 0. Therefore we will get lambda plus 3, then lambda minus 8 is equal to 0. Therefore lambda is going to be minus 3 and lambda is going to be 8. So these are the two eigenvalues. So now I have to find the eigenvectors. To find the eigenvectors, what I have to do is I have to set this equation a minus lambda I to null space equal to 0. So in this case, I can bring the same equation right here. So it's going to be 7 minus lambda, 10, 1 minus 2 minus lambda equal to 0, 0. This is a null space. So 0, 0. Now I had to apply this value. So let's do the minus 3 first. So if I do the minus 3, this will become lambda is equal to minus 3. So this will become 7 minus minus 3, 10. Here is we're going to minus 2 minus minus 3, and the other side we are going to get 0. So 7 minus minus 3 is 10, 10, and in the bottom we are going to have 1. Minus minus 3 is going to be plus 3, minus 2 is going to be 1. So if you see, both of them are same, so we can eliminate one of them by dividing this one by 10 and multiplying negative 1 and adding this one. So you can eliminate, you know, this is not linearly independent vectors, so I can eliminate one of them. So let's do the next one. So it's going to come like 1 1 0 0 when you do the Gauss shadow. So this will become 0. Now you know this is a free variable, this is the leading one. Therefore x, we can create the equation x plus y is equal to, so free variable. So we have to write everything in terms of free variables. So x plus y is equal to 0. Therefore x is going to be equal to minus y. Therefore let's say this is v1, so vector 1 equal to span, first write this one, okay, minus y comma y. Y is free variable, so it's going to be itself. Then I can write this one as minus, I can take y common, so it's going to be minus 1 1. Therefore this is going to be equal to span of minus 1 1. So this is my vector 1. Now I have to find the vector when lambda is equal to 8. It's same approach. So lambda is equal to 8. I bring this equation. So 7 minus 8, 10, and 1 minus 2 minus 8. Then if you do this one, you will get minus 1, 10, 1, minus 10. If you see, if I add them, one of them will become 0. Like for example, if I add R1 plus R2, R1 plus R2, this will become 0. This row will become 0, and we are setting this to null space. So now I can create the equation. This is going to be minus x plus 10 is equal to 0. 10y is equal to 0. Therefore, x is going to be equal to 10y. Then I can write v2 is equal to 10y comma y. Therefore, if I take y common, this is going to be 10 comma 1, and this is going to be span of 10 comma 1. So now we found the eigenvalues and the eigenvectors. So let's see how we can do. So also now we know this from this one, algebraic multiplication is 1 for both of them. So this is algebraic multiplication is 1, and this is also algebraic multiplication 1. How do I know algebraic multiplication 1? Because the power. Because if you see the power of this one is 1. For example, if you get a square, that means algebraic multiplication is 2. So in this case, this is 1. So this is also algebraic multiplicity is 1. And now I have to check the geometric multiplicity. That depends on the free variables. So in this case, first one has one free variable, and the second one also has one free variable. Therefore, both of them are one free variable. And if algebraic multiplication and geometric multiplication are equal for v1 and v2, then it means that this is diagonalizable. So I can do this equation. The equation says if you have a diagonalizable matrix, you can use this formula. That's A is equal to P D P inverse. So first of all, I have to know what is P. So we are remember we are trying to find A power 100. So that's why I'm taking this formula. So in this case, P is equal to what? So P is going to be our vectors. So if you arrange the vectors, for example, we have minus 1 1. So minus 1 1 and 10 1, right? So this is going to be my P. But if you write P like this, my D is going to be something like this. For whatever the vector you write first. In this case, I write the vectors of lambda is equal to minus 3 first, right? So in this case, what I have to do is I have to write that one first and bottom 0. And second one is going to be, so we are arranging the eigenvalues in diagonals. So second one is 8. Lambda is equal to 8. That's what is 10 1. So I'm arranging this into this formula. Now you know I can apply in this formula, but our purpose is not finding the A. We have to find A power 100. But there's another thing. So if A power n is, if A is equal to this one, then A power n is equal to P D power n P inverse. So this is the one we need to find the A power 100. So therefore we can say A power 100 is going to be P, we know this minus 1, 10, 1, 1. Since I don't have enough space, I write in the bottom. So it's going to be P is minus 3 power 100, 0, 0, 8 power 100 multiplied by minus 1, 10, 1, 1 inverse. So you can find the inverse using Gauss-Jordan or 1 over AD minus BC. Whatever the method you prefer, you have to find the inverse, and then if you multiply these three together, you will get the final answer. But in this case, in this kind of question, we don't have to fully solve this. You can find the inverse and just show them the multiple. This is the final answer. And that's how it's done. I hope you guys liked this video. See you next time.